So hey, my name is Matt Klein. I am going to do a really high-level overview of Envoy. It'll be an extended version, effectively, of the keynote this morning. So if that sounds boring to you, feel free to give someone else your seat. Fair warning. So let's go into a little history of how Envoy came to be at Lyft. So this is Lyft's architecture about 5.5 years ago at this point. So it's a pretty typical monolithic architecture. Clients, internet, Lyft is entirely cloud-based. So cloud load balancer. At the time, Lyft was a PHP Apache monolith and a single database. So this is how almost everyone starts. It's a typical architecture. And what's interesting here is that even though this is a monolithic architecture, it's not microservices. There's still problems that people are having at this stage that are more commonly talked about in microservice architectures. So networking, observability, we still have different components in this system. We still have database, we still have the application, we still have load balancers. So even in this very basic architecture, it can be difficult to understand where problems are occurring. Are they in the database? Are they in the monolith? Are they in the load balancer? Or are they in the virtual infrastructure? So fast forward about 2 years later, and again, this is a common progression for most companies that are going through growth. So we still have clients, we still have the internet, we still have the load balancer, but now we have expanded to microservices. So we still have our monolith. Monolith, has been a little slow, so let's add some HA proxy and some queuing. We're now using a bunch of internal load balancers for service discovery. We now have 2 databases, so MongoDB and DynamoDB, and we now have probably 20 or 30 different microservices in Python. And this architecture compared to the one previous is probably an order of magnitude more complicated. There's more hops, there's more places that things can go wrong, there's more virtual infrastructure, there's some black boxes in terms of those load balancers, so it can be very hard to understand where things are actually breaking. And what we saw at this time in Lyft's history, which is something that I hear from lots of different companies that are undergoing their microservice migration, is that they want to move to microservices for the agility reasons, but then what ends up actually happening is it stalls because developers don't trust microservices. They think they're too complicated. They can't debug problems. They don't know where latency is coming from. And then you end up in the worst of all possible worlds, which is you have a bunch of microservices that no one trusts, and then you have your monolith, and developers just end up adding all their code to the monolith, and that's a pretty bad place to be. So let's talk about the general state of microservice networking within the industry. We've moved from a time in which most organizations are developing using a single language to a situation, whether through just internal desire or through acquisition. We now have organizations that have developed in 5 or 6 or 7 different languages. Lots of frameworks with which people write their services. So we have a real expansion of how people are writing their applications. Lots of different protocols. We have HTTP1, HTTP2, gRPC. We have different databases, different caching, so people are building their applications in different ways. Lots of different infrastructure. We've gone through on-prem to virtual infrastructure to containers as a service. Obviously, we now have functions, lots of different ways that people are building things. Different load balancers. So we've gone from hardware load balancers to virtual load balancers from cloud providers to software load balancers. So lots of different ways that people are doing networking between services. And most importantly, observability. So we're trying to debug these systems through typically stats logging and maybe if you're lucky, tracing. And what you see from the rest of all of these things that are on the screen is that it's very hard to get consistent stats logging and tracing because all of these components, your different load balancers, your different infrastructures, your different protocols, they're giving you different stats. So from a cognitive overload perspective, very difficult to understand what is going on in your system, and that leads to people being frustrated because they can't debug. Then we move on to best practices. So we're all told that we need things like retries and circuit breaking and rate limiting and timeouts. Do developers have them? Maybe. Are they implemented differently in different different frameworks and languages and libraries? Probably. And again, that just leads to confusion and cognitive overload. Authentication, authorization, these are key concepts. Everyone wants them, but sometimes, let's be honest, they can fall to the back burner. So these are things, that might have partial implementations or rollouts. And coming back to the multiple languages and frameworks, we have multiple libraries that people are typically using to solve these problems. So Twitter has Finagle, Netflix has Hystrix. Those are both Java-based libraries. And then you'll see that people will develop different libraries for different languages, but those libraries then have different stats, different logging, different features, and that can be very complicated from trying to get uniformity and making sure that everyone is doing the same thing and that everything is easy to understand as we're doing this traffic between hops. So that leaves us here. And this is where I think most organizations wind up after they start doing microservices without a firm plan around networking and observability, and it can get bad pretty quick. So that brings us to the Envoy project and service mesh in general. So the idea behind the project is that we want the network to be transparent to applications. Obviously, problems are going to occur. So when they do occur, let's make it easy for people to figure out the source of the problem. And like I say in most of my talks, we're all here to talk about infrastructure and to hopefully build infrastructure that helps people do their job faster. But for the most part, anytime the application developers are spending working on infrastructure is time that they're not writing business logic. And that's typically not a good use of time for most companies. So our goal, to the greatest extent possible, is to abstract a lot of the virtual infrastructure from folks so that they can focus on their business logic. So this is a service mesh refresher. Service mesh is very buzzy these days, so I'm sure that many of you have at least been exposed to this a little bit. The idea behind the service mesh is that we have a proxy that is co-located next to every application. So in this case, we have service A, B, C, and D, and there's a sidecar proxy that's co-located with that service. And then when a service wants to talk to another service, it talks to its local proxy. That proxy is going to do common concerns around things like service discovery and load balancing and timeouts and rate limiting. And then it'll talk to the other side. The other side might do some tracing and some logging and some stats. And the nice part about this is that we can have common concerns in that proxy. They can be quite complicated, and it'll work alongside any application language. It doesn't matter what language that application is actually written in. So it's a very powerful paradigm. So from an Envoy perspective, Envoy is an out-of-process proxy, so it would be most similar to an HA proxy or an Nginx, and meaning it's not a library. It's a self-contained thing that you run, and it has a config. It is a modern C++ code base. This was chosen for performance reasons. It is, at its core, it's an extensible, what we call L3, L4 filter architecture. So what this means is that there's a core proxy that does a bunch of things, and then on top of that, you can write extensions or filters. And at the L3 or L4 layer, this operates on bytes. So bytes in, bytes out, you can transform bytes. And what that means is that it can be used to build up on top many different protocols. So Envoy can support HTTP, Redis, MongoDB, MySQL, Thrift, whole bunch of different things. So that's a powerful construct that has made Envoy very popular, is that there's that core code and then there's a bunch of extensions. Obviously, HTTP is very popular. We build lots of HTTP services. So Envoy has a lot of HTTP code. So not only do we allow filters and extensions at the L3, L4 layer, but we also allow at the L7 layer. So we can allow extensions that operate on headers and bodies and trailers. And this allows us to do things that make it easier for people to write extensions around authentication and rate limiting and routing and stuff like that. Envoy was written as an HTTP 2 first proxy, and at the most proxies now, they're still not quite all caught up, but most of them are heading in that direction. But this was quite novel at the time that Envoy was originally put out. And by HTTP 2 first, it means that Envoy was written as a multiplexing proxy from the get-go, and it can proxy transparently from HTTP 1 to HTTP 2 or vice versa, and that allows it to be used for gRPC. It has quite a few different built-in service discovery mechanisms, so whether that be DNS and our dynamic configuration systems, which I'll get to in a second, and it supports both active and passive health checking. So active health check is sending a /health check ping to a host and getting a response, and passive health checking is monitoring in-band traffic, say looking if we have 3 500s in a row and saying, oh, I think that host is probably bad, let me boot that host and kick it out, and we'll see later if it's healthy again. So the combination of active and passive health checking can be very powerful, because active health checking can give you a baseline health status, but passive health checking can give you very fast reaction speeds to when things go wrong. So one of the things that you may have heard of with Envoy is we have our configuration API. This is what we call our XDS API, or Star Discovery Service API. And we've built up a whole number of these APIs over the years. And the idea here is that Envoy, which is very novel for a proxy, can be dynamically configured. So it's been built to have a separate control plane from a data plane. And we've seen over the last few years many control planes written on top of Envoy. So you probably heard of Istio. Now a bunch of the cloud vendors are offering their own hosted control planes. So Amazon just announced App Mesh, or Google has Traffic Director, and Azure has Service Fabric. These are all control planes that use the XDS API to configure Envoy, and there's lots of other projects that do the same. So this API has been very powerful, and that's been pretty awesome. In terms of load balancing, we have lots of different load balancing algorithms. We do priority failover and health checking and spilling and all types of stuff. And observability, right? So as I said before, really when we're managing these systems, we need to understand what's going on. And having copious stats, logging, tracing, super powerful. And finally, from an edge proxy perspective, we would ultimately like to be able to use the same proxy both for service-to-service traffic, middle proxy traffic, and edge proxy, or internet facing, because in reality, these things do the same thing, right? So 99% of what these proxies do, load balancing, service discovery, they're all the same. So from an operational load perspective, just from a cognitive load perspective, much easier to actually go through and use the same software and operate it. So this is roughly what Lyft looks like today. So we have our clients, obviously internet. Now, we have Amazon network load balancers in front. We run a fleet of what we call our front or our edge envoys. We've actually recently, in the last couple of months, finally, after years, gotten rid of our PHP monolith. No more PHP. Mm-hmm. And now we have lots of Go services, lots of Python services. There's a bunch of random one-off other services, C++, Java, Node. And then from the backing perspective, still using MongoDB, Redis, DynamoDB, whole bunch of external partners, stats logging and tracing. And Envoy runs everywhere. We have 100% coverage of Envoy. All traffic at Lyft flows through Envoy. And backing it behind it all is what we call our Envoy manager. This is an XDS server or a config server. So roughly the way that it works is an Envoy boots up with a base configuration. It says, hey, I am this server in this availability zone and this auto scaling group. Give me my configuration. And then I don't quite have time to go into it today, but we have an entire configuration pipeline that will inform what configuration that Envoy gets. And then that configuration can be dynamically updated in real time without restarting the proxy, which is very, very powerful, very useful from an operations perspective. So this is generally what Lyft looks like today. So From a Envoy deployment perspective, we have many hundreds of services at Lyft now. We run Envoy, depending on time of day, on many tens of thousands of hosts, anywhere 5-10 million plus requests per second that run through the entire mesh. The majority of it is HTTP2, service-to-service traffic. All of our edge, service-to-service, most of our external partners flow through Envoy. So those are things, for example, like DynamoDB, where just having global visibility of applications that are talking to DynamoDB across our fleet makes it much easier to identify problems. Is it specific to a host? Is it specific to an availability zone? Is it specific to all of DynamoDB? And there are countless examples of times where we have gone back and forth with AWS reporting issues and been able to highlight either global information or logs from Envoy that have given us confidence that it's an Amazon problem, and it makes that debugging back and forth much faster. And we're still obviously, so that includes Mongo, Dynamo. We do all of our Redis, clustered Redis through Envoy, and that's many, many, many tens of millions queries per second against Redis. Lyft is a very heavy Redis user. That's been a very nice system for us because it couples Envoy's dynamic configuration, eventually consistent mechanisms, with support for Redis and consistent hashing. We're still working on our configuration management system. Since we built Envoy at Lyft, we've gone through many iterations, from static configurations to templated configurations to our dynamic configuration manager, and that's just the natural way of things. So yeah. In terms of adoption, as I said this morning in the keynote, for those of you that were there, we open sourced Envoy about 2.5 years ago, and adoption has been truly incredible. I think beyond our wildest imagination. We're now being used by all 3 of the major cloud providers. Many large peer companies. There's lots of companies down on the show floor that are building their technologies on top of Envoy. So it's been a pretty amazing ride. From a why Envoy perspective, I talked about this morning, but I'll expand on it a little bit more. I think we've been able to keep quality quite high while actually still moving fast. So through modern development philosophies, by using GitHub, by doing CI and all that good stuff, we've been able to keep high quality but move fast. We've really, again, focused on extensibility. And I already talked about, filters at L3 and L4 and L7, but we have lots of other extension points. We allow people to build their own stats plugins and their own tracers and their own retry policies. And there's probably 7 or 8 or 9 different extension points right now, and we're always adding new ones. The general philosophy is that we want to build a core piece of code that people can build into interesting vertical solutions. I already talked about the eventually consistent API. That's been very powerful. The API used to be in JSON with a JSON schema. We've since moved to Proto 3. Proto 3, in my opinion, is a real tech success story. It's pretty awesome in the sense that allows you to have typed APIs, but actually convert back and forth between a structured file and JSON and YAML. So we allow people to call these configuration APIs using JSON or YAML if they want, or they can use gRPC and have it be structured in whatever language gRPC supports. So that's been really fantastic. And as I was saying this morning, Envoy, there is no enterprise Envoy. It is a pure community-driven project. And unlike some of our competitors, that has frankly allowed us to make technology-first decisions and not worry about, we need to save this advanced feature for our enterprise product. So that's been really, really fantastic, and I think has made us very, very competitive and very, very compelling for people to pick up. And from a community perspective, because of the no enterprise version, and just because of our goal of trying to bring on maintainers and have everyone be involved, we've built up, I think, a pretty amazing and passionate community, which has been fantastic. Yesterday, we hosted our first EnvoyCon. We had like 350 people, really amazing. Can't believe that all these people showed up, so that was great. Thank you. That's a brief intro. Stop there. We have plenty of time, like 5 or 6 minutes, to do a little Q&A. I can pass the mic around, or you can call out questions and I can repeat them. So thank you very much. Sorry, encryption of what? So the question is, can Envoy be used for encryption? Sure. In fact, we have a lot of people that are building mutual TLS solutions and various types of encapsulation systems based on Envoy. In terms of data going to a volume, I think it depends on what protocol that is, and I think it would depend on a particular use case. But there's no technical reason that Envoy could not proxy data to some service and perform encryption on that service's behalf.
Usually, Envoy is described as running in a sidecar in a container in the cloud. Can it be used in a bare metal?
Question is, Envoy is typically associated with service mesh or sidecar. Envoy, we see it now being used in a huge variety of use cases. We see it being used on bare metal. We see it being used as an edge proxy. We see it being used as a middle proxy, as a standalone server, or as a sidecar, or as a daemon set. I think what we've tried to do with Envoy is we're not prescribing a particular use case. We're building a building block that allows people to build a whole bunch of different solutions. I was going to ask. So the question is challenges of adoption, and is the question within Lyft or outside of Lyft?
Maybe both start with Lyft.
Within Lyft, I originally I thought that it was going to be difficult. Like I thought that we were going to build this thing, and we had deployed as an edge proxy, shown a bunch of value. We had deployed it on our monolith to help with MongoDB proxying and a couple other things. And I had really thought that we were going to have to take the stick approach of let's get everyone on the list and let's whip them until they upgrade. And that's kind of what I thought was going to happen. I was very surprised in the sense that we made a concerted effort to provide people value immediately. So we made automatic dashboards that worked if they were using Envoy. And we gave them special logs and abilities to debug and all these kinds of things. And what we saw, frankly, at Lyft is that once people saw the benefit of particularly the observability between 2 points, it was mostly a carrot thing. I was really shocked. It was not hard. We had people upgrading. We just gave them instructions. We had, it took some time, of course, but did not really have to chase down very, very many people. On the external front from adoption, I think what's been most interesting is before we open sourced, I didn't know what to expect, so I thought, it would be great. I would be so happy if we got one of Lyft's peer companies, say like Pinterest or Yelp or Slack or a similar size company. Wouldn't it be great if one of them used Envoy? So before we open sourced, I went around and talked to a lot of these companies and gave presentations, and everyone told me, this is great, but we don't have time to go and do this right now. And I was sad, and we open sourced and didn't know what would happen. And what was interesting actually from a public adoption perspective, it was actually the biggest companies that came first. So Google showed up before we even open sourced. They found out about it somehow, and Apple came very soon after, and then other big companies. I think the larger companies had the time to invest in this, and they saw some of the potential, and they had more people or more projects that were dependent on it. And then I think over time, just with the momentum of getting more industry weight behind it, and then just the control plane and Istio, and now all the products, I think we just have a snowball that keeps going.
I see examples using Envoy to discover other services running in Kubernetes. Are there comparable patterns for using Envoy to discover legacy services outside of the Kube infra?
Sure. So the question is, we see patterns of Envoy, finding Kubernetes services. How do you do it outside? Envoy itself actually does not know anything about Kubernetes. Really, all we offer is these generic discovery APIs. So there's an API around the endpoint discovery service, which helps you find endpoints. And when we first put out Envoy, we would see a bunch of queries come in about, well, will you support ECS, or will you support Kubernetes, or will you support Docker Swarm, or whatever. And what we found pretty quickly is that people stopped asking, because I think the discovery APIs are simple to use, they're easy to understand, and they're compelling. And two, very often people want to customize the behavior in some way. So like just supporting Kubernetes ends up not being that useful. People want to have some intermediate translation layer that actually has some control over what is discovered. So everyone just ended up implementing our APIs. So there's tons of examples out there now of people that have Envoy running against almost all of these systems, whether it be console or Kubernetes or something else. But the Envoy project itself doesn't support Kubernetes. There's a question, I think, over there. The question is, in Istio, we've seen a bunch of 500s during ungraceful termination. What do you mean by ungraceful termination? Right. I can't really speak to Istio. What I would say is that that's where a combination of passive and active health checking comes in. So typically at Lyft, we run with both active health checking and passive. And typically when something gets killed, we use passive health checking to fail it out very quickly. So I would follow up with the Istio folks. There's one over here.
Yeah, so my company is now going towards Kubernetes deployment and protection. So should we go with Envoy plus Istio service mesh, or just Envoy should be sufficient just for the observability?
The question is, we're going to deploy. Should we use Istio or should we just use Envoy? Unfortunately, that's it's a deep question. There's no one answer there. I will give you a general answer, which is that Envoy is a Swiss Army knife that can do a lot of different things. Like as was asked before, people use it for edge proxy, for service proxy, for middle proxy. I think whether you choose to build your own control plane on top of Envoy or use Istio, or now there's Console Connect, there's App Mesh, there's all kinds of things, right? I think that's a decision that you'll have to think hard about in terms of where you want to spend your resources and how tied in you want to be to a particular control plane implementation. I would say, quite honestly, that to use Envoy directly requires a fairly high level of networking expertise. So I think that's what you have to weigh in terms of whether to go one way or the other.
Istio also uses Envoy proxy.
Yeah, right. But Istio is a combined system that offers an opinionated control plane plus Envoy. So unfortunately, there's no quick answer there.
Okay.
I think we have time for maybe one more. Yeah.
Usually with a lot of observability, there's a tax to pay performance. Have you guys benchmarked any typical use cases?
Sure. Yeah. Yeah. The question is perf impact. So how much does Envoy add? We don't actually officially announce perf numbers, and the reason for that is that with this type of software, very hard to actually accurately measure perf because it depends on the features that you're using, like the system that you're running on, a bunch of other stuff. I'll say two things. I think in many or most use cases, we see people measuring overhead in the sub-millisecond range, so high microseconds to 1 millisecond range overhead per hop. I also think that there are some people within the community that are doing some really incredible work around performance and Envoy. So there's the Cilium project that's using BPF. There's talks at this conference about it. And they're doing really wild and crazy stuff to really minimize a bunch of that overhead. So I guess my standard answer here is I think everyone needs to measure for themselves to see what the overhead will be. Answer 2, the performance is always getting better. Answer 3, typically the features so far outweigh the performance loss that I think for all but a tiny number of installations, it just doesn't matter. Cool, well thank you. We are doing a deep dive in like 20 or 30 minutes in here where we'll just be doing pretty much Q&A for the whole time. So if people have additional questions, feel free to stick around. Thanks.